All right, so the first 4 are all the ones so far that need to be highlighted. And let's take a look at how the relationships exist. So if you look at the first one, same side interior angles postulate. What I want you to do first of all is take a look at the picture. Take a look at the picture. Do you see how it makes sense that they called that same side interior angles postulate? So let's break this down. Let's think about this. Same side. First of all, same side of what, do you suppose?
The transversal line.
Smart. Good. Transversal line. I love how you use that word. Transversal. Same side. And then interior. What do you suppose that means?
Inside.
Inside. So the way that I like to think about this is the parallel lines are like that peanut butter and jelly sandwich. Those are the pieces of bread. Inside that sandwich, those parallel lines are interior. And then outside of those parallel lines, you'll have exterior, which will happen in a minute here. All right, so are they congruent or supplementary?
Supplementary.
Perfect. Supplementary, yes, it says it right here. And then also, can you notice how one is acute and one is obtuse? All right, perfect. So that's the first one we need to get comfortable with. While we talk about these, I'm going to pass the stapler around. Can you get your blue sheet and staple it to the purple sheet, please, too? Just so it's there. Okay, next comes alternate interior angles. Stay around. Alternate interiors. Again, break it down. Take a look at the picture. Okay, alternate. Now do you see the difference between same side and alternate? Alternate has the opposite sides of the transversal being used. Still interior, still inside the parallel lines. My question to you is, did they miss a set? Is it possible there's another pair of alternate interior angles here that haven't been labeled?
Mm-hmm.
Yes. There is. They aren't labeling every alternate interior angle, which is important to note, but they are just showing you one of those relationships. If I wanted to put 3 and 4 in, wouldn't that also work? All right. So alternate interior angles are supplementary or congruent.
Right.
Congruent. Perfect, perfect. Next one in line. Corresponding angles. So if I had to pick one that was the hardest to kind of figure out, it's this one. Corresponding angles. How did you think about it then? Like, what was it that clicked in your brain?
I was on the same side, so they're both there.
Yep.
They're easy to find. Like, I got all of them right. Everything else.
Oh, really? All right, never mind. Maybe I have it backwards. So the corresponding ones, yeah, they're on the same side of the transversal, true. They're also, but the way that I like to think about it is, so this is one parallel line up here. This angle is sitting in the upper left. Upper left, upper right, lower left, lower right. So this is in the upper left. Where is this one?
Upper left.
Also upper left. So corresponding sits in the same location on both parallel lines. Congruent or supplementary?
Congruent.
Congruent, perfect. Last one for us today. So the alternate exterior angles theorem. See how it's outside? So it's alternate, yes, opposite sides of the transversal, but it's also outside. So that's the external component there. Alternate exterior angles. And again, congruent or supplementary.
Congruent.
So there's only one pair marked as supplementary. The rest are congruent. Okay. So we're going to do today, so here's what I was thinking. We're going to today do the proofs that I had set up for you tomorrow originally, if anybody was on the Google Doc. But I'm going to go ahead and do the proofs with you today so that tomorrow it will be a work day. Tomorrow I have a Pearson, it's a lesson 2-1 Pearson exercise for you. It's just a homework set of questions. It's mostly algebra. So you'll be doing like, it'll have x's, it'll say 2x plus 3 equals 170. So you'll have to know that they're congruent, set them equal to each other, and write an equation. And I can show you a little bit of that before I leave today, or before you guys leave today. But anyway, so tomorrow you'll have a Pearson homework assignment, not around proofs, and then I'm going to have you try 2 on this packet. But that'll be what you'll bring to me on Wednesday. Sound good? Is that you?
No.
Oh, you're good. It's fine. It's no big deal. So anyway, I'm doing the proofs with you today, which is a brutal Monday activity, but I thought it'd be better than trying to do it on your own tomorrow. Get that packet out for me, please. The one I passed out to you. Okay. So, let's do some. Let's take a look. I kind of like going by ourselves first and then coming back to the one that's filled out. So I'm on this packet. I'm going to go to question number 2 first. What I want you guys to do right now is to put the 3 steps for writing a proof at the top of your page, please. Talk in groups, see if you guys can figure out what the 3 steps for that is.
Given.
It's where you just think. I like this recognition. Oh, the given through and then highlight.
Definition, so hopefully.
There you go. There you go. Okay, I finally heard it. So given definitions, and the keys for definitions are equality versus congruency or words. And then highlight the proof, which is using the postulates and theorems stuff. All right, perfect. So we're going to start by just taking a look at, getting statements and reasons and our given down. So they're using the diagram up above. I wish they had it down below a little bit better because it fit better on my screen, but I'll just redraw it. Some key information about parallel. You know what? They don't define parallel. It's kind of an assumed word. Do you guys know what parallel lines are? Okay, never touch, right? They never touch. If you have a set of parallel lines, it's really common to have an extra arrow on them, which just forces you to understand that they're parallel. So those extra arrows show, hey, for sure those 2 lines are given to us as parallel. So we're given parallel. Step 2 has a definition for words or equal versus congruency. Do we have either of those things going on in our proof? Do we have any words so far? Do we have any congruency or equality issues at this point? No. So now we jump to the 3rd step, which is highlight. Highlight the proof. So we're going to go in and we're going to highlight angles 2 and 8. It'd be helpful if I had numbers, I suppose. Is there anywhere that I can highlight the numbers within the statement? Obviously not. So you highlight on the diagram. Okay. There is a theorem that we just talked about. Oh wait, I lied. Whoops, hold on. I have it labeled wrong, don't I? Okay, there is a theorem, so now you're right, Daniel. Now say that louder. Alternate exterior. That could be used technically to prove 2 is congruent to 8. But what they're not telling us, which is sneaky, and I don't appreciate this, but what they're not telling us is that we're writing the proof for alternate exterior angles. We are writing the proof for that specific theorem. So it's just like any kind of definition you would give to anybody if you're going to define a crazy word in science. I don't know what word you're even learning. But would you use that word in the definition? Are you allowed to do that? No. We are doing somewhat of the same thing. We are proving alternate exterior angles, which means you are not allowed to use it. It is not allowed. So we can't use it. We have to use other theorems that we have highlighted to get there. So 2 and 8. We need to bring 2 and 8 into this proof. So give me another theorem that would bring 2 or 8 into the proof. Yes.
2 and 6 are corresponding, and then you can make.
Let's do that first. All right, angle 2 is congruent to angle 6.
I don't think that's gonna work then, because you don't have one for 6.
Oh, you're good. I
But
got you.
then 6 is vertical to 8.
I wouldn't write it down if it wasn't a good idea. What? Somebody said something.
6 is vertical to 8.
Nice job. Corresponding angles. And in all honesty, for as many number of people that there are in this class, there are that many different ways to write this proof. So if you had seen something different, it's quite possible that would have worked also. So anyway, we're going to bring in 2 by way of corresponding angles. 2 and 6 are congruent. I love Emma's thinking. Well done, Emma.
Yay.
Yeah, yay for you. That was great. Vertical angles is a big one that is going to be used from chapter 1 over and over and over again. So vertical angles, although it's in the blue sheet, although it's a chapter topic 1 theorem, it comes up again and again. So I am now in a position where I can use the postulate property or theorem that allows me to cross off the same number. You guys remember what that is? Yeah. Perfect. Angle 2 congruent to angle 8 because of the transitive. So, had you chosen to go with something other than corresponding, you could have gotten there, but you likely would have had to have some type of vertical angles and a couple of transitive steps. So it's a fairly similar setup. All right, you guys get to talk amongst yourselves to see if you can try number 1. Just filling in the blanks on number 1. Pretty similar. Talk it through. Make sure you and your group agrees. Ready, set, go. All right, period 8, you should be doing the same thing. I want you to get into your groups and talk about number 2. So you can just keep rolling the tape, but talk about it. I should hear you talking, or talk.
So angle 8 are corresponding. Then that's just trans. The last one is just trans.
Property equality.
Transitive property of
Property down.
Yeah.
You gotta think about it there for a second. I'm like,
So vertical.
just with slightly different numbers. But only slightly.
I love
Awesome. Good. Okay, so you just got to see it again, right? Pretty similar. You had to use vertical angles and then transitive property of congruency, otherwise fairly similar. I'm going to give you another one. Tomorrow you'll try to do one similar to this by yourself, and I'll tell you what that will be eventually. And then you're going to try to do one similar to the number 4 by yourself. So let's get into number 4. And again, we're just gonna do the one from scratch first, together. We'll build from there. So go ahead and if you need to redraw your picture, Put your given down, please.
Maybe your spring t-shirt vibes is good.
Alright. I'll try to number it right this time. Their numbering system is a little bit odd, though. You have to agree with that. Okay, 1, 2, 3, 4, and then 5, 6, 7, 8. That's not intuitive. All right. So the given is in. Do we need to define anything, words, or congruency versus equality?
Oh, no.
Not yet. Will there be a definition at some point in
Yeah.
this proof? Good. Yes, because there is a word at the end at the proof. So good. That's a good catch. There will be a definition at the end. All right. So we go to the highlight step. So I want to go ahead and highlight 2 and 7. Okay. Now, if it's a quiz or a test, I will be very open about the fact, hey, you're proving such and such a theorem, don't use this theorem. I will be very clear about that. That is not a gotcha game. Here, before we start, is there a theorem that this correlates to, or is this a fair game proof? Anything is good. Yeah, this is not any specific name. So this would be same side exterior. We don't have that. So we can use any postulate theorem we want. So right now, and again, like I said, there are about as many different ways as we want as students in the room to get there. So whoever says something first wins. Why don't you kind of contemplate as a group quickly how you would bring in angle number 2. Let's just start there. Kind of contemplate which theorem you want to use to do angle number 2. And I'm going to pick randomly and you are the winner. Figure out what theorem you'd like.
Would that just be, what, it would be vertical, corresponding
You could do choose vertical 3 and 3.
Alright, Ava, I'm going to pick on you.
Oh,
Am I too fast?
Same side interior to 5 and 5 vertical. So
so corresponding.
Or can do the inside. The first one in equals.
Yeah, so would it be that?
So what you said was good, Ava, which is why I put you on the spot. I didn't put
Okay.
you on the spot because what you said was bad.
Okay, I was just trying to like
Yep.
not bankroll myself. What I would say is corresponding angles theorem, except they're both. Never mind. I don't know what's
No,
what
that's
you're
okay. So it's gonna go a lot of different directions. You could do, some people might try vertical right off the bat, because I said something involving angle 2. So you could have said vertical angles, you could have said corresponding angles, you could have said alternate exterior angles. Truthfully, anything that you would have said right now would have been okay, as long as number 2 was involved. So I'm gonna bring number 2 in by corresponding angles, just because I guess I heard Ava and I first, and I just went with it. So let's do that. So we're going to say, are corresponding angles congruent or supplementary? Good. So angle 2 is congruent to angle 6 by corresponding angles. So I can highlight 2 because that was good. Now, the catch is once you have another angle brought into the proof, is to try to use that angle to bring in the other one. Okay, because I don't want to have many, tons of angles in this proof. As few as I need are awesome, are best. So is there a theorem, this now everybody has to look, there's one answer here. Is there a theorem or postulate that would allow me to bring 7 in using 6, since I've already picked that? Ready, set, go. Start looking. Purple sheet, blue sheet, anything's fair game.
Same pure angle postulate.
Yes.
Same pure angle postulate.
Wait, it has to involve 6 and 7. Has to involve 6 and 7.
Oh, yoke.
Super big hint. It's blue sheet. Blue sheet theorem. You guys get the circular here.
Yeah, just vertical angles here.
6 and 7.
It's not
So 6 and 7 would not be vertical, but 6 and 8
Oh,
would.
linear? Linear.
Are you sure?
Yeah, it's linear. Linear. I call saying
Okay. Okay. Alright, Brandon, what did we do?
linear pairs.
Good. So are 6 and 7 vertical, first
No.
of all?
No.
Because that's a really awesome use if you can, but 6 and 7 aren't vertical, 6 and 8 are. So 6 and 7, do you see how they form a line? And Elena was explaining that really well too. If you kind of hide that, so 6 and 7 now make a line, and they're going to be supplementary. So let's bring so let's put linear pair theorem in first, since we know what that is. Alright, now, this is being picky, but I believe being picky is important as we start writing proofs. And then as you get really good at it, then I can start to kind of release some of that, be a little bit less picky perhaps. But, so if they form a linear pair, this is what we'll put into our proof. We use this theorem, so this is what we will put into our proof. So that becomes our statements, except it's not measure of angle 1 and 2, right? It's not always 1 and 2. What is it in our case here?
6 and 7.
Okay, so. Alright, now we have the 2 that we needed in our proof. So that's a really important start. Now we just need to bring them together to show they're supplementary. You see it? Do I have a discrepancy with congruency and equality?
Yeah.
Good. So I'm going to change from congruency to equality because of that problem, that issue. Okay, so here I can raise it up a little bit. So I am taking step 2, which is a congruent piece, and I'm changing it to equality. You can't take a congruent thing and plug it into an equality piece. It has to be the same. They have to talk to each other.
Shouldn't that be 7?
What did I do?
On 4, measure of angle 6.
Oh, hold on. So I'm coming from here, literally just taking step 2 and rewriting it. So I measure of angle 2, and then I'm going to keep it equals
okay.
measure of angle 6.
Oh, okay.
And then, do you see where I'm headed?
Yeah.
What do I want to be brought together? What do I want to exist together?
7 and 2.
So what can I do?
Transitive.
Transitive would work. I'd let transitive go because it very much feels like a transitive. There's something else I would let go as full credit. Substitution property, yes, good. All of those are of equality. But yeah, substitution or transitive property of equality would count. I would let either go. So measure of angle 2 plus measure of angle 7 equals 180. And you pick if you want subs or transitive. And then, feels pretty good to end there, but you have to catch yourself because it's not the prove statement. The prove statement, it has the word supplementary into it. So how do I do that, Brendan?
Definitions.
Perfect. what you're gonna do right now, this is kind of the end of class here. Go ahead and cross off statement number 4, just because you're gonna fill it in, and that one we're just crossing off so that it matches what our textbook shows us. So right now, at the end of class, I'm gonna put all these instructions on your plate right now, so I can turn off my board video, 8th period's watching us. But this will be our to-do in class, and that will end our period. Okay, that'll be it for today. Tomorrow, you'll have a Pearson textbook thing with algebra, and then everybody look at your questions. I think it's 15 and 16. You're gonna try those. Yeah, right here. You're gonna try 15 and 16. So just try them. Don't freak out about them. Don't make them so hard that you're stressed. Just come with something attempted on 15 and 16. So that'll be what you bring to me Wednesday. You'll try 15 and 16, but you'll turn in the Pearson online component. All right? Perfect. Go ahead and go back to the front page, and we'll call it a day.